So let's look at this problem now, trapping rainwater. It is marked hard, but it's still considered one of the mediums. So the problem statement says that you are given this map of these are heights, an elevation map wherein each bar is of one size, and we have to basically compute the overall water. So in this example, we can see the second index can hold at most 1 because at left of it there is a elevation of size 1 and on right of it there's of size 2, but we have to take the minimum of that because the water will overflow from the second onwards part. Similarly, all of these can be calculated. For the fifth index, let's see, there's already a height of 1, but in the left there is a maximum of 2 and on the right there's a maximum of 3. So minimum of them is 2, so that is why it can hold a water up to this level subtracted by its height itself. So you get the idea. What I am basically doing is I am looking at the leftmost maximum height and the rightmost maximum height from a particular index, and whichever of them is minimum, I am finding that the addition should be that minimum height subtracted by the height of that bar itself. So a brute force approach can be to go to every index and then separately look for its left max and then separately look for its right max and do it for every index. But that is pretty time consuming. So for every index, if you try to search what is the maximum height on its left, that will take n size, and to search for what is the maximum on its right will also take n, and this we will do n times. So that would result in big O of n square time complexity. It won't pass. So a better way can be to pre-compute this left and right max arrays. So what I mean is that for every index I will pre-compute whatever is the maximum possible height on its left and whatever is the maximum possible height on its right. So in order to do that, first let's make our left height and our right height. Alright, and I have marked this as size n, where n is nothing but the size of my height vector. Alright, now we also need to initialize it with something. So left height of 0 would be the same height, the first index basically, so that would be equal to height of 0, and same goes for right height, but we'll be computing it from the rightmost, so that is why it will be n minus 1 here and n minus 1 there as well. Okay, so we have already computed for the 0th, so let's look at the 1. So this will be nothing but my left. I have to keep track of the maximum. Okay, so left height of a particular index would be the max of left height up to the previous index and also considering the current height. Okay, and similar code would be there for right height as well. So for right height, it will go from n minus 2 up till 0, I minus minus, and yep, same thing. This will be I plus 1 instead, because we are computing from right to left. Okay, so by this code we have formed our left height and right height arrays. Now the formula is pretty simple. For first, let me declare an answer variable. We will initialize it to 0. Now for every element in this, and we will just be going from 1 to n minus 1 I plus plus. Now we have to first find the minimum height, and then we should also check if the minimum height of the left height and right height of a particular index is greater than the current height of that index. Only then it will add on to the answer, right? For example, if we look at this example, the fourth index, which the height is 2, the left height is of 1 and the right height is of 3, but the minimum is still 1, and 1 is smaller than this 2, so it is of no use to us. So we will only count if our minimum of left height I and right height I, if minimum of this subtracted by my current height is greater than 0, only then I will add it to my answer. So answer plus, I will just store it in a variable such that it is easier to read. So int current is equals to this. If current is greater than 0, only then I will add it. Answer plus current. Alright, and at the end I will return it. Let's run it and see if it runs fine. Okay, missing semicolon. Alright, so it runs fine. Let's discuss the time complexity and space complexity of this solution. The time complexity is pretty easy, since this is one loop of size n, this is one loop of size n, and this is another loop of size n. So it's basically big O of 3n. And space complexity, since we are using two additional arrays for left height and right height, space complexity is 2n. So will the interviewer be happy with this solution? There is a better solution. So if you observe, at a particular index we are keeping track of both left height and right height, but we don't need to create arrays in order to keep track of it, because at most we will just require one value, right? One for max of left and one for max of right. Okay, so let's not have this. Instead, let's just create two variables, which is max of left, and I will initialize it to my height of 0, and another would be max of right, to which I will initialize to height of n minus 1. Alright, okay, so we don't need this pre-computation here. Let's have int answer is equals to 0 here, and then let's have two pointers, okay, left and right. Initialize these two pointers first. My left is equal to 0 and my right is equal to n minus 1. Alright, so now what's the trick? How do we decide which pointer to move? In the last problem we did container with most water. In that problem we moved the pointer which was affecting our answer, right? And that's the thumb rule. Here also we will move the pointer which is affecting our answer. And which is affecting our answer? Whichever is smaller, max right or the max left. So whichever is smaller, we will move that pointer. Okay. So let's have this. If my max left is less than max of right, then what do? I move my left pointer. But before doing that, I also need to see if my current of if my current left is greater than my previous left or not. If it is greater than my previous left, so I will have a if condition which will say my height of left, if it is greater than or equal to my max left, I will update it. I will make my max left to point to this height of left. Else, if that's not the case, then I know by this if condition that my max left is smaller than max right. And if my height of left is also smaller than max left, then it means that I need to add it to my answer. So my answer would be nothing but my max left minus height of left. Alright. And we would apply the same logic in this case also. So I'll just copy it for the right part. So if my max right is smaller than my max left, then over here I will move it to right. My max right will be equal to my height of right, and my answer would be max right minus my height of right, and this will be right of minus minus, and at the end I just return my answer. Let's submit. Let's see run it and see if it passes our sample test cases. Okay, we are getting incorrect answer. Let's see what sort of mistakes are we doing. Okay, we are getting wrong answer. Let's see if we did any mistake here. So max left is height of 0, max right is height of n minus 1. Answer is initialized to 0, left is pointing to 1 and right is pointing to n can be minimum of this. Minimum n can be of 1. Okay, alright. Okay, and my max left is less than max right. If that's the case, okay, let's say that there are just two numbers. If there are just two numbers, n minus 2 will be equal to 0. So this condition won't hold true if there are two numbers. If there are three numbers, let's say, if there are three numbers, if my n is equal to 3, then my left is 1 and my n minus 2 will also be 1. But in that case, there can be a middle index which can form our answer. So this should be less than and equal to instead. Alright, we are passing it. Okay, so slight modification here, but very important in the context of problems. So we need to visually analyze it. Once you visually analyze, it gets much easier. Okay, so what's the time complexity of this solution? It's the same. We still have the two-pointer approach. So the time complexity is big of n, but the space complexity is now constant since we are not using any extra arrays, just a couple of variables, 4 variables. So it's constant. Let's submit it. Excellent.